Alrighty, we're going to go ahead and start off over here with unit number 7. And this unit is going to be on mathematical equations, okay? So what is the big thing we want to go? What do we want to do? Our goal is we want to be able to solve one-step equations, okay? And so that's something like this. Whoops. 2x equals 8, or maybe like x plus 1 equals 5. And also we want to solve two-step equations. Okay? And those would be more like 2x plus 1 equals 7. Something like that. Okay? So what is an equation? An equation is a math statement that has two mathematical expressions that have the same or equivalent value. We use an equal sign between the two equivalent expressions. So remember, equivalent means equal. Okay? Math equation is like a sentence in English. So that's different from a math expression. That was our last unit. Unit 6 was math expressions. It's a well-formed combination of mathematical operations. Remember, our operators here are plus, minus, multiplication, division. We have the square roots, etc. Those with the variables and constants. A mathematical expression is a phrase in a language sense, not a complete sentence. Thus, we do not use an equal sign. So what are some examples? So we can see examples here. These are equations, because they have, and the easy way to tell, they just have an equal sign here. Okay. And by the way, these are equations. They must be true. They must be true. So these are not math equations. This here is an expression. This is an expression. This one, if you look at it and distribute this, 16 times 7 is going to be, what is that? 70 plus 42. And it's going to be 112. Minus 64, and that's not going to be equal to 54 minus 9. So this is false. So that's why it's not one. This is an expression, and this is also an expression. Okay? Next page over. So which of the following are mathematical equations? Okay? So you should go ahead and do this one over here. You go ahead and pause the video and see if you can do it out. And then I'll do it right now. So this here is an expression. So not an equation. This is an equation. This here, we have to check if it's true. So let's see, that's 5 plus 8 is 13 times 2 is 26. Is that equal to 26? Yep. So this is an equation because it's true. Here, let's check. That's negative 33. Oh, sorry. So negative 11 plus 6 is going to be minus 5 times 3, which is negative 15. And then 22 minus 7 is just 15. And these are not equal. So this is not an equation. Okay. Here, if you notice, we have two equal signs over here. So this one is also not an equation. And this is just an equation here. All right. So down over here, we're going to go ahead and skip G. So solution to an equation. Mathematical equations often include variables. For example, x plus 4 equals 7 is an equation. The solution set, so solution set means the possible kinds of answers of this equation are all the values of x which satisfy. Satisfy means to satisfy the equation. It means it makes the equation true. Okay? The value of x equals 3 is a solution because 3 plus 4 is 7 is true. X equals 5 is not a solution of this. Because 4 plus 5 is 9, it's not 7. It's false, the solution set is 3. Okay? So when we have the following, so for example here, what is this talking about here? When you have x plus 3 equals x plus 3, what does this actually mean? So what values of x satisfy this equation? So in other words, if you put like numbers in here, right? So in other words, well, if x is 2, then, let me say, if x is 2, then you have 2 plus 3 equals 2 plus 3. And if x is 5, 5 plus 3 equals 5 plus 3. Notice you can't have different values because it's the same x. So for example, you can have 3 plus 3 equaling 5 plus 3. Why? Because these have to be the same number. So this would not work. And so what's the solution set here? So in this case, it would be all real numbers. Because any value you put in here will make it true. Versus this one over here. X plus 2 equals x plus 5. What will work in here? And the answer is nothing. Why? Because if you notice, if you put any number in here, the same number, it has to be the same. Like 1 plus 2, is that equal to 1 plus 5? Of course the answer is no. Why? Because this gives me 3, which is equal to 6, which is of course not true. And so this solution set here is empty, so there's no solution. Okay? Actually, you wouldn't even write that. So technically, you would write the empty set, or you would say just no solution. Okay? All right. Okay. So over here, in general, when we're given an equation, sometimes we can just kind of guess and check to see if it's correct. So sometimes that's a nice thing to do. We can just kind of guess and check. So for basic equations, it's fairly easy to guess and check the solution of the equation, but pretty quickly we'll come across some equations that make this method totally impractical. Okay, so we need to we need to build reliable techniques and rules for transforming equations so that solutions is more obvious. Okay, so we have the equation 1/2 x plus 5 equals 16. So it's 1/2 of a number plus, 1/2 times some number plus 5 is equal to 16. So we can kind of use guess and check here. And so, I mean, what could we do? Well, I mean, like, for example, let's just say x is, I'm just going to pick something random, 8, right? So half of 8 plus 5 is what? That's going to be 4 plus 5, which is 9. That's not what we want, so we have to pick something bigger. How about what? How about 20? Does that work? So 1/2 of 20 plus 5 is 10 plus 5 is 15. We're close. So what about what? 22? So 22, half of 22 plus 5. Half of 22 is 11 plus 5 is 16. So x is 22. Oh, sorry. Yeah. So we can determine x was 22. So this is an example of how we might kind of guess and check. This one. All right. And so we need to figure out some of these. In general, there are certain properties that will help us figure out the answer without guessing and checking. And these are our properties of equality. We have the addition property of equality here. It says I can add something to both sides. So you always start with, like, for example, c equals c. If I add a to both sides. I'm sorry. If I have, let's just say a equals b. And if I add c to both sides, that's what we have over here. I added, same thing over here. If a equals b, and let's just say I want a minus c. Let me put it as a minus c here. And that's the subtraction property of equality. Again, if a equals b, now I'm going to multiply both sides by c. That's what we have here. That's the multiplication property of equality. And if a equals b, I can divide both sides by c, so long if c is not 0, because we can't divide by 0. And that's just the division property, which is listed here. Okay. So what you should do now is we want to label each equation with the property it illustrates. Okay. Which property? One of these properties of equality. Or state the equation is not true. Okay, so we should do this one here. So what are you starting with? You're starting with P equals Q. So here, if P equals Q, what did I do to get here? I added 5 here. So what property is that? That's the addition property of equality. Okay, here. So what do I have here? I start again with P equals Q. Okay, and what did I do here to get to this one here? Well, we want to subtract 7. We kind of want to. So notice over here, what am I doing? I have like a both kind of a minus 7 here. I'm adding a negative 7. So if I minus 7 to both sides, okay, and then what I'm going to do is, so I can rewrite this as, negative 7, let me write it, yeah, so negative 7 plus P equals negative 7 plus Q, and now, what I can do is I can divide everything by a negative, and which gives me 7 minus P equals 7 minus Q. And so what property did I use? I actually used 2 properties. I used the subtraction property. So this is the subtraction prop of, I'm just going to put an equal sign. And also this is the division property. Okay, sorry, it's getting a little messy there. Here, clearly this is division. Okay, here, what do we have here? So this is again, division. The division property here. This is not true. Why? Because if I multiply by 3 to both sides, if I multiply by 3 here, it has to be 3 here as well, and that's not true. Okay, here this is the multiplication property of equality. And here I'm multiplying by 3, that's correct, but I added 2 and I added 7, so this is just not true. So whatever you do to one side, you just have to do to the other side as well. Okay? So when you're solving over here, what we're going to be doing in this next section is we're going to be solving equations using tiles. Okay? We will do that in our next video.